Good morning, hello, happy Coding Train Wednesday. It is me, your host, Daniel Schiffman. And I'm here yet again to talk about discrete Fourier transforms. So I know I've been. You might think that I have an unhealthy obsession with this topic about Fourier transforms and how they apply to drawing paths, but it's just been something that I have seen and thought about and looked at and wondered about for quite a few years now. I never felt that I really understood or certainly knew how to implement. And so the recent things that have popped up in my peripheral vision on the internet. Smarter Everyday video, the Turkish website article written by Doga, 3 Blue 1 Browns video. There was actually a wonderful podcast called, I have to look this up. It's let me just look this up because this is a really one, I don't want to get this wrong. A wonderful podcast that I listened to called Too Much, Not Enough. And the hosts are Darius and Emma. And they have many wonderful episodes. I highly recommend it. But season 2, episode 1 is called, I don't know if you can see this, Fourier Transforms. So it's a really wonderful, excellent explanation. You would think like, oh, how could I ever possibly listen to a podcast about Fourier Transforms? Just listen to people talk and explain and think and consider Fourier Transforms. And yet, I couldn't imagine a better podcast to listen to. So this, though, I think I've got to move on with my life. But it's time. I need to do one more thing. I need to do the part 3 of the Fourier Transform Coding Challenge, in which I will, and in a way I probably should have started doing it this way, but to figure it out, to get my brain to learn it and understand as much as I can about it. And I had to start by separating out the X's and the Y's. And if you recall, if I come back up here, this is the result of the first part of the coding challenge, where I apply a Fourier transform to a signal of all the X values of this coding train logo path. Then I apply a Fourier transform to the signal of all the Y values of this coding train path. I turn those into these circular epicycles and use one to grab the Y and one to grab the X, and then reconstruct the drawing. And you can see this strange artifact here where actually in this one, the X never changes. Even though all these circles are rotating, epicycles or orbits are rotating around each other, this X value stays the same. And here the Y value stays the same. So now it's time to take both of those and put them into one and achieve something perhaps even more magical than what I have achieved already here on the coding train. But this will involve some stuff like complex numbers, which it already did, but it will involve more about complex numbers. It will involve revisiting this formula, but I'm ready to go. I'm going to make this happen, and I hope it's going to work. So then, topic number 2, which I don't know that I will get to, I mean, it would be great if I got to it, is, and someone in the chat just asked, Vedang asks, what does KNN stand for? And KNN stands for K nearest neighbor. So the logical follow-up question would be, what does K nearest neighbor mean? And K stands for K? Yeah, all these are very legitimate, good questions. If I have time, I will get to KNN classification, and I will be demonstrating an example that was pioneered for the ml5 library by Yining Shi, who has been a guest on the coding train before, and I'll point to a lot of her materials if and when I get to this topic. But the idea is to create a game controller with basic gestures. How could KNN, K nearest neighbor, possibly do that? Well, stay tuned. But if I don't get to that today, I will be back on Friday. What I would this week marks the first week of the NYU semester. And I had class yesterday. It was okay. I did my best. That's all I could do. So it's busy, but I also am back a bit more into the routine of things, and I'm hoping to try to do more than one live stream per week and have each of them be slightly shorter rather than these sort of like long 2, 3, 4 hour live streams. I would much prefer to do twice a week for like an hour and a half each time, or an hour and a half to 2 hours. I think once I get to, once I get to about 20 minutes, which I'm getting close, that's when I start, I don't know if I ever think clearly, but it really starts to go downhill. But certainly after 3 hours, if you've watched any of my live streams, you might find it entertaining, but it's a little less productive. So, something like starting your day with a nice like math formula just to like sort of settle in and stare at. Let's do some deep breathing meditation. Oh, let's read some random numbers to the discrete Fourier Transform formula. 5,551. 87,189. 14,067. 57,901. I lost my place because I'm looking up at the Fourier Transform formula, and yet it's not actually there. I can't even reach that high. And right now this is the word expression, but really it's just a green wall. It's just a green wall. There's no words there. 93,057. 19,873. 66,201. 98,001. Okay, I feel like that's what we needed to calm down, to ease our minds, and to allow ourselves to feel like we can tackle this today. Uh-oh. Is the mic muted? So, no, it's not muted. Okay. So I'm a little bit concerned. One thing I'm going to need your help with. I'm going to need your help with this because usually I have these rechargeable batteries for the microphones that I use, and usually they've been charging ever since I left the studio the last time I was here. Did forget to charge them, so I charged them up a bit this morning. This one is on 1 bar. That one is on 2 bars. I've got some charging here in the charger. So if the mic goes out, then the music is very loud. I can make the music a little quieter. Let me just fix that for a second. Okay, I made it a little quieter. If the mic goes out, you're going to have to do everything within your power to channel your mental energy to me to get me to notice like the chat. Can we come up with like a signal? Although no, I don't want to. I'm worried people are going to start trolling me. But the signal would be like emojis of microphones over and over again. Should we practice it like a one? Just get it out of your system, like everybody all at once. Everybody all at once. Just like when I clap, just flood the chat with microphone emojis and just count to 10 in your head and then stop. Or count to 5. Count to 5 in your head and stop. Okay, ready? And this will be the practice. While I'm waiting for you to catch up to me, it was asked, what is this book? This book is 1,000,000 random digits with 100,000 normal deviates. This is not an original print. If anybody could find where one could purchase or acquire an original print, it would be like my treasure, my absolute treasure. This is a book published by the RAND Corporation in the 50s, I believe. Yes, the original publication date is 1955, and it was used as a list of random numbers for different kinds of Monte Carlo simulations and experiments, because there were no computers that could quickly, well, not that there were no computers, but having a computer at your fingertips that could generate lists of random numbers to very quickly was not possible. It also has a Gaussian distribution, a normal distribution of random numbers in the back. All right, great. I see all of the microphone emojis. That is something I will definitely notice if the mic goes out. Okay. I'm being told by Simon that there is a video. I have seen this. Michael says primes for 3 hours. I don't know. I need a good. If I ever hit 1 million subscribers, I would like to read all 1 million random digits. Now I did the math for that. Even if I could read like one, think about it. If I could read 1 digit per second, it would be. I think that's 1 million. Divided by a 60, that's how many I could do in a minute, and there's how many, minutes in an hour divided by 60 again, and how many hours in a day divided by 24. It's a lot. It's a lot. So I'm trying to come up with a solution. I thought, well, maybe I could read from the book for. I got to come up with something. Something that relates to 1 million. But doesn't involve if I could do 1 million milliseconds, but then I think that's not, could I read anyway, you'll think of some idea. Ben Morin in the chat says an original $275. I would spend $275 of my hard-earned super chat money on a million random digits. By the way, K. Weekman in the chat is saying, and Simon, by the way, said 277 hours. That's a lot. I actually think there was issued corrections to it since the numbers weren't random enough. What does it even mean for something to be random enough? It's really an interesting topic if you think about. How could it not be random enough? If it's not random enough, isn't that kind of like randomly not random? Which is even more random than random? So, I don't know. The question is there a detectable pattern? Is the actual distribution of numbers over time uniform? There are so many things we could get into and talk about, but I must talk about discrete Fourier transforms. That is what is going to happen. Miayem Sumi seems to think that 11 and a half days of reading the random number book straight is doable. Okay, I'll do that for 10 million, if it's 10 million subscribers. How about that? I actually have 10 million subscribers. Maybe I would sit here for 11 and a half days. I'd have to sleep. It's very unhealthy not to sleep. I'm like an oldish man. I can't do the young person stay up marathon for 11 and a half days. Anyway, can I take breaks? Maybe I could do it over time. I could do 277 hours over a year. Maybe I just have 1 year to read them all. I don't know. Let's not come up with this. There was a super chat in there. Someone's giving me donations to buy that book, I guess. Mr. Ugla going toward the book. So I have a new system. I need more and better systems, but I have a new system where I can see new memberships and new super chats. I always feel awkward about the existence of these sorts of things. They do help me fund various things I want to do for the channel, make it more possible for me to do this. But what I always feel the most guilty about is if people ask a question with a super chat and I miss it. So my new thing that I'm going to try to do is before I leave, before I end a session, I'll always go back and check if there are any questions there. I will answer them. We'll see how that goes. All right. Okay. 13 minutes in, we've got to get going with, I won't do the drum roll whole shenanigans again, discrete Fourier transform. I'm looking at my email, which I don't need to be looking at. Okay, here, back into the Slack group. All right. And Anurag asked, are you going to do fluid dynamics? Thank you for asking. Okay. I'm going to go to Rainbow Topics. I'm going to sort by recently updated, and I am going to go here. So if you haven't already seen, why am I not logged in? I won't worry about that right now. If you haven't already seen the Smarter Every Day video about laminar fluids, and I don't want to start some kind of YouTube beef thing or anything. I'm like small potatoes to the giant that is Smarter Every Day, and I'm most likely just going to get squashed. But I like turbulent flow. I really like turbulence. If you visualize it and it's all crazy turbulent, it's really cool. So, trust me, laminar flow is cool also, but I kind of like turbulent flow. Just saying, just a little, just putting it out there. Turbulence. I don't like it in an airplane. I'm a very nervous person. I have to grip onto the sides like this. like I fly. I just recently was on a trip. I think was sitting next to my 10-year-old son. It was very turbulent, like holding on to him with dear life. He's just like looking at his iPad, whatever. Okay, that aside, turbulent flow. I would really like. There's this really nice demonstration that I found doing fluid simulation. I believe this is using this lattice Boltzmann algorithm. I'm going to hit start, and you can see here. Let's make it all turbulent. Look at all that turbulence. Can I add like, how do I, flow speed? If I make the speed much higher, let's change the viscosity. Oh, we want the viscosity. There we go. Look at that turbulence. Look at that. Come on, turbulent flow. Mwah! So I would really like to, make this. I mean, in a way, it's like, oh, look, this already exists. I mean, this is basically exactly the coding challenge that I have imagined that I want to do when people ask about doing like fluid dynamics. I have to admit, I have no idea how to do this. I have at one point, I have used the Navier-Stokes particular algorithm. Which is super interesting, and I've used several libraries that implement it. You know, when I'm making a project, if I need to make a project that has fluid simulation in it, I'm just going to go and use a library probably. But when I'm on this channel and I'm trying to do a tutorial, I like to kind of figure some stuff out a little bit more lower level as a sort of academic exercise or for fun times. Because there's like more fun times than trying to figure out how to code your partial differential equations that you don't understand at all. But I'm hoping that maybe I would do this on Friday. But I think this requires some research. Like, I don't think I can come in here cold and just like read the paper. I don't need to write code in advance, I don't think, but I need to read the paper and look at some of these examples and have a better sense. And I wouldn't do anything this sophisticated with like an interface and everything, but I just want to get basically something like this working. So, turbulent flow. We are going to make some turbulence happen with the lattice Boltzmann algorithm. If you have some suggestions or ways that I could tackle this, here's another paper. Please contribute to this thread. Oh, and this is really cool. This is somebody's like JavaScript 2D fluid turbulence simulation. I mean, come on. If this were just laminar flow, all of the little dots would just be going, we're laminar flow. But if there's turbulence, it's like, all right, enough shenanigans. Let's get to the discrete Fourier transform. That's right, Destin, I'm coming for you. All right. So, all right. Let's see. I'm sorry. All these interesting things people are saying in the chat. All right, let's close this out. Send me your ideas and help and everything. And here we go. Oh, before I go to start with the, by the way, clearly this is the only thing I'm getting to today. Before I go and start with the drawing with the Fourier transform, let's look at some of the things that people made. Now, there were only 2 community contributions. By the way, I think there might be a website, but it's not really a website bug, but one of the things we really struggle with the website is when a coding challenge has multiple parts, where do people share their parts, and then where do people find them? And I believe the way the system works is if you share your parts with part 1 of the challenge, then it ends up being in all the parts. But I just noticed here, if I go to part 2, this one, the community contributions aren't there. So I think, whoops, and I think we probably didn't link them correctly. So anyway, we'll talk about that in the patron Slack group for those of the website contributors that are there, but that's a minor thing. Let me show this. Oh, look at this. Simon writes, so I did not know this. The Navier-Stokes algorithm is an algorithm that plays out in 2D. And there's lots of wonderful examples of it. It's because, I'm assuming it's saying it's because part 1 is named wrong. Okay, I can fix that. I even know how to fix that, thank you. In 3D, we don't know if Navier-Stokes will even work. It's a $1 million prize. All right, coding train enthusiasts, let's go solve that prize. I don't know. That's probably for like some other YouTube, not for me. You might have some way of thinking about it that my brain does not solve $1 million prizes. Someday, maybe. Apparently, it might almost some point get 1 million subscribers. I don't know if it's my brain that's getting it or my just winning personality. I think I got to start coding. Whew. Okay. Yeah, good luck with that. All right, let's stay within my wheel. All right, I'm going to cycle the cameras. Oh, no, I was going to look at the community contributions. Apologies. All right, so this is Epicycles Redrawing with a User-Drawn Loop by ILM Narayana. And so looks like if I let me draw something like a figure 8. And then I'm going to hit Start. Oh, I love that. Do I have to press a key? Oh, I press a key, maybe. Or maybe it just took a while and got it. Now we can see. This, by the way, is exactly what I'm going to do. I'm going to expand this to work this way. So you can see the epicycles are tracing the path, but there's one set of epicycles rather than two, one for the x's and one for the y's. And I like that I can, I love that you can do this with the slider. Whoops, I got. All right, so there's some interface stuff that, one thing I guess if I'm giving feedback here is like, it's beautiful, it works great. I'm not really sure how to operate it. It was doing like a really cool thing where it was like computing it and almost like the lines are just kind of like wiggling into the spot, and that was sort of beautiful, but I didn't know, does start mean start the epicycles, start my drawing, reset? Oh, is that, so that might be something to look at there. Now, Rainbow Orbits Unicorn Train Driver by Juan Carlos Ponce Campuzano. Let's look at this one. Oh, this is P5 Web Editor. And there we go. Oh, what I love about this, so this is, I don't know that I'm going to necessarily, actually I might have a way of showing how this works, but look, this we can increase or decrease the number of orbits. So for example, if we just have 2 orbits, this is all we get. And the camera went off, that's good. So this would be a great feature to add to mine once I get it working as well. So you can see this is what happens when you only have 2 orbits, 28 orbits. So Gruselhaus just made a wonderful GIF. All you need is now to put like turbulent flow is the best, or I don't know what, some funny like meme text, turbulent flow over laminar flow or something. I'm not see, is it 20 minutes now? This is exactly when I stop being able to speak or make any sense. That means it's time to tackle a complex mathematical formula. Anyway, this is great. This is basically showing you exactly what I would like to do today in this coding challenge. Epicycles, approximate curve. Oh, look at that. Oh, I love this. Oh, that is wild. So you can kind of approximate the curve based on the number of epicycles. That is really cool. Okay. All right, so guess what? I mean, if all goes according to plan, in about an hour, I'm going to leave. I don't know if I'm going to do that KNN thing today. In about an hour, I'm going to have exactly that. And all the code for it, and I will have explained it. And I am also going to start from this. So I'm going to start from this and start from this. Okay. So actually, before we get started, I would like to write this formula up on the whiteboard. So please listen to the this dot song. As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do dot, this dot, this dot. I'm over here writing. I need to see the screen so I can't switch to the whiteboard camera. This dot, this dot song. This dot, X sub n. Never forget this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot, this dot song. This dot, this dot, this dot. I'm going to do the this dot, this dot, this dot, this dot, the this dot song. Never forget the this dot. Somebody compose that song for me. All right, almost done here. Whoops, I missed something. Give me a second. I think I can show you what I'm doing here. I'm just writing out the formula so I have it for reference. So big X sub n, right? I'm at n here. No, sub k, right? Big X sub k equals summation from n goes to 0 to big N, well, n minus 1, of little x sub n multiplied. And this is sort of a dot product, and I'll get to why that is. Okay. All right. I feel like I want to switch the battery on the mic. So what I'm going to do is I'm going to mute the mic for a second, just so I know that. Okay, I should be back. Now I have 2 bars, so there's less of a chance of it going blank. Okay. Sorry. I'm all tangled up here. Okay. I'm ready to go. Need the code up here. And here we go. Okay. All right, so by the way, if you haven't watched my live streams before, I waste a lot of time, mostly, and then I attempt to do a coding challenge or a tutorial, and later the different pieces of it get edited into smaller, shorter, bite-sized videos that end up in different playlists. So now is the time where I do the weird thing where I pretend I've just like showed up here and nothing that happened in the last half an hour happened. Okay. Hello, it is time for yet another video about the Fourier transform in epicycles. Now, you might be asking yourself, what? Why? I mean, what's wrong with you? What's this weird, unhealthy obsession you have with Fourier transform? That's a good question. I'm not so sure, actually, but I do know that there is absolutely, at least, if not more, one thing that I feel is very important to demonstrate to you as part of this series, this now 3-part coding challenge about drawing a path with the epicycles, and the discrete Fourier transform algorithm. All right, so what I want you to look at here from the previous coding challenge is this. This is the coding train logo being drawn by 2 sets of nested orbits. And the frequencies, amplitudes, and phases of these orbits are all calculated from the discrete Fourier transform algorithm. The discrete Fourier transform algorithm takes, it's over here, and this is going to look like, what? Are you crazy? I'm not going to watch the rest of this video. But just stay with me, or don't stay with me, but stay with me if you feel so inclined. Don't worry if this looks crazy and weird to you. I'm going to help you through it. And actually, I did this already, and you might want to stop and go back and watch that first video. But what the discrete Fourier transform does is it takes any signal, and that signal is sort of represented here by x sub n, signal. And you can think of the signal as really just a list of numbers, 1, 5, 10, -3, 7, 9, 4, right? It's just a list of numbers. It's saying these could be the x values of a path, they could be the y values of a path, they could be the values of a sound wave. There's so many types of things that this could be, and it takes this signal and breaks it down into a collection of wave patterns. Each wave pattern has a particular frequency, frequency meaning how many cycles does it repeat within 1 unit of time. So how many repeats per second, you might think. 60 hertz is 60 cycles per second. It also breaks it down into, so there's different frequencies, but there's also different amplitudes and different phases. So is this wave pattern like actually a little bit offset one way or the other? Is it much taller? Is it much shorter? It breaks it down, and I can visualize those wave patterns as rotating circles. Okay, so that's a lot. That's a lot there. I'm sure you have questions. Maybe, hopefully, some of this stuff is covered in a bit more depth in my previous 2 videos, or, of course, in the supplementary material about the Fourier transform that I'm including as links in this video's description. I've talked about those way too much, but in particular, I'll highlight the 3 blue, 1 brown video about the Fourier transform that you might want to check out, which goes into this in more depth. Now, so here I have 2 sets of signals. I have x's. Oh no, this is y's actually. I have y's, and over there I have x's. I treat them separately. I apply the Fourier transform to each, and then I render out these rotating circles and get this path. What I want to do now is treat the signal. The signal is not a list, a vector, an array of numbers. It is an array of pairs of numbers. So we could think of the signal as, x1 of a path, x1, y1, x2, y2, x3, y3. And this is a really useful way of thinking about it because so much in computer graphics is this. Vector graphics, scalable vector graphics, SVGs, those are really just defined paths, collections of points. Now we can do all sorts of crazy math if these points actually mean like draw a Bezier curve between them, but I'm going to do this in the simplest way, and this is just, if this was my path, I would have 3 points, x1, y1, x2, y2, x3, y3, and I would want to create 3 orbiting circles to be able to render out this path. That's what I want to do. So what happens when the pairs of numbers go into this formula? Well, guess what? If you watched my first video, I talked a bit about how this is actually something known as a complex number. A complex number is a number that has 2 components. A real component, a real number being the numbers we're kind of familiar with more often, and a quote-unquote imaginary number. Now, the fact that it's called imaginary is unfortunate naming. It's somewhat misleading, but the idea is that it is a real number paired with the number I. And the number I is the solution to the problem I squared equals -1. So this is often referred to as an imaginary number because it's kind of like, what? The square root of -1? You can't square something and have -1. But yet, you can. There is a solution to this. That's a topic for a Khan Academy video, a math video. But if I can treat any one of these points as a complex number, x1 plus y1 I, and that's actually what I was doing before. I just was leaving out the imaginary component. I just had a whole bunch of x's and a whole bunch of y's always in the real component. So if I can actually have this signal be in a list of complex numbers, I could have this be complex numbers. This is already a complex number. Then I just need to know, how do I multiply 2 complex numbers together? You got that? Sort of, maybe? Let's go write some code. I'm going to go write some code because there's more to do over here, but I think you need to take a moment to breathe and absorb that a little bit and write some code. Okay. Hold on, pause for a second. I don't understand K. Weekman. Oh, yes. Okay, so a couple things. People in the chat are mentioning, I suppose the more traditional way to do this would be you would say x squared plus 1 equals 0. It's the solution to this. Maybe I'll come back and mention that. That to me is the same as this, but maybe this is like an unconventional way to write it in mathematics. So maybe I'll mention that. Then I don't understand Kay Weekman's comment. There no phase differences actually, or there's no offsets. What does that mean? Did I get something wrong there? I thought the phase is like the offset of where you start the angle. That GIF is really distracting me in the chat. In the Slack channel. So before I move on, let me see if any of those things were like wrong. Just say, I said the square root of -1 before and somebody complained that that's like not the proper way to explain it in the comments. So I was trying again. I'm very, very susceptible to user feedback. No, not wrong. I guess my question for you, Kay Weekman, is do I need to go back and clarify something? Or is your comment just like additional information that's interesting to discuss? Thank you for all the comments about the haircut. I appreciate it. I got this haircut from a wonderful new barber in Brooklyn. I'm going to go there forever now. It's kind of expensive. He also shared with me some like a beard oil that I've never used in my entire life, but I'm trying to be a more well-groomed person. The eye explanation is perfectly fine. What about the phase one? Is the phase one fine? Do I need to say something about the phase? No need. Okay. 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 Okay, so now we're coming back to the code. Oops, what's wrong? Oh no, all right, I gotta do this. Okay, let me cycle the cameras while I'm here. I'm gonna check the microphone. I still have 2 bars there. And I have 2 bars here, so that should be pretty good. And drop the, Ziggy asked for me to drop the beard oil name, but no, I'll wait till they become a sponsor. Thank you very much. You can tweet at me, I'll send it to you. I don't want to this is not a buzz marketing YouTube channel. Unboxing, maybe I'll just switch to an unboxing beard oil channel. Okay, here we go. All right, so if we go back to the code where I left it off from this previous iteration, which I have right here, I had a particular JavaScript file, Fourier.js, where I had my implementation of the discrete Fourier Transform algorithm, DFTX. X being exactly that x sub n over there, the array of the signal, the array of numbers, and then big X, whoops, where am I going? This freaked me out here. And big X being the array of complex numbers that came out that I get the phases, frequencies, and amplitudes. Okay? So what I want is to rewrite this so that little x is actually an array of complex numbers. And I think one way that I could do this is to actually put here, I'm going to write a complex number class. Now, if you're paying attention, or if you've used p5 before, you might be thinking to yourself, oh, just use p5.vector. Because actually, I'm just going to swing on here over to the Wikipedia page about complex numbers. Look at this. This is how you represent a complex number. It is a vector in the complex plane, where what we think of as the y-axis is the imaginary axis. What we think of as the x-axis is the real axis. And right here it says a complex number can be visually represented as a pair of numbers, a, b, forming a vector on a diagram called the, I never knew this, Argonne diagram. Ooh, look at that. More stuff. So I could just use the fact that P5 has a vector class, but I kind of want to take the time to really think this through, and I need to do complex number multiplication, which is different than just like a vector dot product, perhaps. So it's similar, but anyway, so just let me do it myself. So I'm going to write a constructor. I don't know whether I should call these A and B. Maybe, so one way to do is like is A plus BI. I think though I might stick with the real and imaginary. So let's say real and imaginary, but I'll leave these A and B. So this is my complex number. So this is what I wanted to do first. So I just have a complex number, and if I go back to the main sketch, instead of having two separate x and y variables, I'm going to get rid of this. Let's get rid of y everywhere in this code. In a weird sort of way, I'm kind of simplifying things. Let's get rid of y everywhere. Well, I'm not going to worry about this right now. I'll come back to this in a little bit. Let's comment that out. And so what I had before, again, you probably want to watch the previous video, is I have this big file that just has a ton of xy points for the path of the drawing. And I separated them into separate x and y's. And now what I'm actually going to do is say constant c equals a new complex number with the real component as the x and the imaginary component as the y. And then I'm going to push that into x. So that array is now an array of complex numbers with the x and y's. And in fact, then I want to go here and say, like, you know what? I don't need to treat these as separate real and imaginary components. I have this idea. I'm going to call it like the sum as a new complex number with 0, 0. Then the idea is I could say sum.real plus equal, sum.imaginary plus equal. Right? I'm going to treat this as a complex number object with two components. The problem is this is no longer correct. So everything is right, but this no longer flies. This asterisk is multiplication. Cosine of phi is a floating point number. It's like a complex number with no imaginary component. X, previously, x index n was just a single number. So I need to rethink how these, because this is now a complex number, how do I multiply a complex number with another complex number? I have to completely rethink this. Okay. I kind of took a long time to explain that, but why not? So the next step is for us to work out complex number multiplication. So typically, if I'm going to want to implement complex number multiplication in my source code, I could actually just look up the formula for it and put it in the code. But I don't know. I got a little extra time today. I started early today. Let's actually do it here. So if I have two complex numbers, let's say I have a plus bi, and I want to multiply that, and often this is referenced as the dot product. This is exactly what I have here, by the way. I want to multiply that by, let's call that c plus di. Then how do I do that? Well, guess what? What's this multiplication property called? Commutative? I think it's commutative. I'm going to have to stop and look that up. I'm over here, commutative property of multiplication. Come on, just give me like an image to show me I'm thinking about this correctly. No, commutative is this? Oh, here, commutative, associative, no? Identity, no. No, commutative is any order. No, associative. No, associative. Distributive. Thank you. Thank you. Yes, distributive. Thank you. I knew it was wrong. All right. All right. Record scratch sound. A commutative is the property of multiplication or addition where I could do these in either order and I would get the same result. The distributive property is the one that I'm looking for, where I can say A times, well this, A is going to distribute, multiply times C plus this. So I'm going to say A times C plus A di, right? A times C plus A times di plus bi times C, which is I could write as bci, plus, well, this is crazy, this is the fun part, plus bi times di, which is b di squared. Hey, guess what? Remember how I wrote up on the board over here, I squared equals -1? By the way, somebody pointed out that the traditional way you might see this written is like I is the solution to x squared plus 1 equals 0. You can see that's the same thing. X squared equals -1. Or you could also think of it as the square root of -1, although somebody, a YouTube comment I had earlier said that's not a good way to describe it, but whatever. This is -1, so guess what? This becomes -1, which means this is just a minus. And now a complex number is real and imaginary components. What's the real component? The real component is AC minus BD. And the imaginary component, also I could pop out that distributive property again, is AD plus BCI. So this is the real component, and this is the imaginary component. We have just done, I don't know I just can't believe this, the coding train first, complex number mathematics. Now the truth of the matter is, I could probably spend a whole video, many videos, building out an entire complex number class, but I'm just going to stick to what we need, which basically is just the multiplication. FOIL. Oh yeah, I've heard this called FOIL. First, outer, inner, last. Yeah, I've heard that. FOIL. FOIL. Oh yeah. First of all, did I get that right? Let's just check it. Complex number multiplication. No one's saying I did it wrong. AC. Oh, did I use the same naming? A plus BI, C plus DI. AC minus BD plus AD plus BC. Yes. Okay. Great. First. All right, just in case, just to be sure, I quickly Googled how do you multiply complex numbers, and the same notation is here, and the same answer, dare I say, is there. And then I was also reminded, also by the chat, that there is an acronym, FOIL, for a way of remembering this. First, outer, inner, last. First, outer, inner, last. I don't understand what that means. What does the first, outer, inner, last refer to? FOIL math. First. Oh, I get it. I get it. I looked it up. I figured it out. First is you first multiply A and C together. Then you multiply the outer, which is A and D, right? Oh, wait, hold on. First, outer, inner, last. First, outer, inner, last. We've got a new coding train song called FOIL, 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 which also could stand for F-OIL, which would be a useful acronym as well in our day and age. Okay, now, all right. Let's move this along here. We might have to edit that last little bit out. so I don't get flamed in the comments. All right. Okay. All right, everyone. Okay, we're getting close. So now I need to just replace these two lines, right? I need to replace, oh, actually, let's do this in a different way. Okay, sorry. All right, so now, okay, we are ready now. We can add a function here called multiply, c. So c being another complex number, and I want to create the answer is a new complex number, and the answer's real component is first, multiply the first of each, which is this. This is a's and the complex numbers a, plus oh, whoa, first, outer, inner. Oh my God. Wait, hold on. Let me. Sorry, I let myself get way too distracted. Let me come back to this. So I'm going to implement, I was just going to write the answer here, but now I have this complex number class. So let me do a multiplication function. Okay. Mathieu, RE, not A. Yes, exactly. Ah, okay. So confusing. Okay. All right, it's time now. What we can do is take this result that we've got here and add it to the complex number class as a multiplication function. So let's imagine I am saying I have a complex number dot multiply another complex number, which I'll call C. And so the one complex number is this, and the other complex number is C. So I need to make the real component is this real component times, I'm looking over there on the whiteboard at this formula, times C is the other's real component minus this real component, this imaginary component, because it's written as B over there, times the other's, D is its imaginary component. Okay, and then the imaginary component is this real component times the other's imaginary component plus this imaginary component times the other's, what's C? C is the other's real component. Let's take a moment to meditate on that and wait for the chat to tell me I did it wrong. And then I'm going to say return a new complex number with this real component and this imaginary component. Okay, so now I should be able to say sum dot add x index n. Oh, I need a new complex number. Okay, so I also need, now I need to make a complex number. I'll call it C for what? Where's my marker? I need to make a complex number that is cosine of this and negative sine of this. Okay, so this is I did this before, but I just never bothered to separate it out. So my complex number is a new complex number with cosine of phi and negative sine of phi. That's the complex number. And then if I take x sum dot add x sub n dot multiply c. So I want to add up this complex number multiplied with c added up to the sum. What does that mean? I need an add function. And so if I go back to the Fourier class up here, I can write an add function which also takes a complex number, and I just add the real components together and the imaginary components together, like this. Now, I've done something sort of terrible here where the add function adds to this particular complex number rather than returning a new one, and the multiply function returns a new one, and that's definitely an opportunity for refactoring this later, but I'm going to just leave that for now. This is not good object-oriented programming design. Maybe I want one to be static, but I'm going to leave that as is. Whew, okay. Then I can say sum, and I'm just going to do this. Let's just leave this. I could write a divide function, but I'm just going to leave this as this. And I think, dare I say, this is now done. This is now the version, and somebody in the chat is telling me I've made a mistake, so hold that thought. This is the version of this algorithm where this array is no longer just an array of floating point numbers, but is an array of complex numbers. All right, what did I get wrong? C, not other. Where did I write that? Where did I write other? Ah, yes, this is C. I was saying other in my head, oops, but it is C. Thank you. So let's just see, dare I say, let's just console log Fourier x and see what I get. RE is not defined, Fourier line 33. I'm sure I've forgotten. Oh boy, I forgot that now all of this is in an object. Again, I should put in the complex number class a magnitude function and an angle function, but I'll just do it this way, and then I have to say this. I'm just gonna, this really should be refactored, but I will leave it like this just to see if it works. Great, so here we go, and we can see what does it look like. I have a real component, I have a frequency, I have a phase, I have a real, where's the imaginary component, huh? Okay, let's go back. Imaginary component. Let's try that again. I have, in each one of these, a real component, an imaginary component, you can't see this, a real component, an imaginary component, a frequency, a phase, and an amplitude. Those are all the things I need. Now, we're not going to know if this worked till I try to draw it. All these numbers, they're there. There's no not a number, but I'm just going to hope. There's a lot more code for me to write before I can actually run it. So that this timpani sound is premature. All right, so a couple things. One is it's complaining to me that there's some leftover Fourier y in sketch line 58. Oh, okay, well that's just the length. I only have Fourier x now. Whoops. No errors. This is a long timpani sound. So I just need to do the epicycles. This is stuff I wrote in the previous coding challenge. It's calculating all the epicycles based on a particular Fourier series that was calculated from the Fourier transform. I don't need separate Vx and Vy. And I can just, basically, this is actually simpler now. I don't need these lines. And what I should be able to do is, there. It should actually just be this. Ironically, it's a lot simpler, right? Because all I need to do is get all the epicycles. The epicycles return this function epicycles, which I never liked that I capitalized the C. So let's fix that. This epicycles function basically goes through and calculates all the x, y positions of the circles and angles. It was done before, but the same function should stand. And now, oh, there's still an error in the, hold on. I'm being told that there is still an error in the multiply function. This times RE, this, real, wait, this, CC, this, CC, real, imaginary. Real, minus imaginary, real, imaginary, imaginary, real. I think it's right. It looks right. It looks right. Error line 14. I think the problem is some people watching in the chat are like from 10 minutes ago, and so they're seeing the error. I'm pretty sure I fixed it, the error that they're referring to. Okay? So Mathieu, we can, in post, I don't think we need this extra check that I just did because I think it actually was fine. Thank you, thank you, thank you. This coding challenge is now done. Look at that. Woo! All right, so that is the Fourier transform. Now, okay, quickly. Let's not go just yet. I really vastly prefer the version where the user has to draw their own thing. So, oh, and there's so many things we could do. You know what's interesting about this? This video needs to end, but here's something you could try. Like, for example, where am I doing the epicycles? So in this epicycles function, I am doing all of them. But look what happens if I just change this to 1. Right? That's just doing just the first epicycle. If I change this to 2, these are just 2 epicycles. And I could speed it up, potentially, if it's a lower number. This is 5. So you can see this is the coding train logo kind of with smoothed out and sort of much more primitive with only 5 epicycles. You can kind of see how the contour of the cloud, that like sort of like cloud rainbowy thing is there. But certainly, you know, I'd have to get up to like 50, and we can see with 50, we can start to see, oh, this looks much more like it, but it's much curvier. So there's a lot of ways. And also, I kind of like, one thing I like, so that's one thing you can try. Another thing you can try is I think it looks just really interesting without drawing the path. So like, what happens if I don't draw the path? And also, what happens if I don't draw the circles? I really like just looking at this crazy thing. Because if you look at this, could you possibly imagine what it's doing? But I could then, so I could create an interface where I change the way I'm visualizing it, use different colors, speed up, slow down, vary the number of epicycles. That's a lot of things you could do to sort of play around with this idea. I think what I would like to do right now very quickly, however, is go to this one, user drawing. So this is another version of the coding challenge that I made where the user just draws something. And very quickly, let me bring in my new discrete Fourier transform algorithm to this one, just so we can see this at play. So what I'm going to do is I'm going to go over here to Fourier.js. I'm going to paste it into here. And so I now have the new algorithm there. Then I'm going to go into Sketch.js. And the drawing is, so again, I don't have x's and y's. Just the x's. And the x is a new complex number with the x and y of the drawing as a component. Just want to see how quickly I can get this to work. Then I'm sorting it. And then all of this is the same. And then here, this is just creating the drawing offset by the middle of the screen. And then put that offset in here. Same sort of thing. I can just change this. I don't like that that function had the capital C in it, so I must fix that as well. A little refactoring now instead of later. I can get rid of these lines, and here we go. And now, 26, I'm missing a parentheses. Need another parentheses here. And now, all right, let's see. I'm going to draw a little cat. This is going to be really sad when this doesn't work. It has to be a continuous path. It'd be interesting to try to do this without like a continuous path. Ah! Oh, you can see it did it. It calculated it, but I need a better sound than that trombone thing. It's a little cheesy. I mean, all of this is cheesy. Fourier y is not defined. I better not do an elaborate drawing next time before I. So let's just do it really quick. Okay, now it works. Okay. But do my cat now. Oh. Hold on. So now this really is the end of the coding challenge. There it is. Fourier transform of a complex number series into orbiting epicycles, drawing this beautiful meow, 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 meow. You don't have a cat sound? It's cat. Thank you very much for watching. If you make something from this, please share it with me. One thing you might try is go look at that quick draw data set from some of my previous coding challenges, or maybe the sketch RNN machine learning model. Those would be interesting things to combine with this, right? I think there's some interesting possibilities there. Okay? Mwah, mwah, mwah. See you soon. Oh, K. Weekman is saying, try an approximate version. So I can't do that because I didn't store the points. I mean, I could do it again. I could add that to the drawing. What time is it? 11:30. Huh. Well, this video is going to be a half an hour. Less than that. This won't be a really long coding challenge. Am I crazy? Because I started at 10:30. I wasted a half an hour. Now do it in 3D. Oh my God. Yeah. You do it in 3D. What I think is also fun to do with this, I'm going to lose that cat now, is I could draw a heart. No, that's not what I was. That's a nice one. Actually, simpler drawings almost have more interesting. But what I meant to do, not that, is I meant to just actually see how close to a circle I could draw. Oh, that's terrible. And you could see, like, that's pretty interesting to see, like, how close. Now I could try to trace this circle. Like, how perfectly of a circle can I draw? Oh, yeah, that's pretty cool. Like, look at that. That is wild. I love that. Like, to see that basically that's the error. It's the error of the circle. So what would it look like with just, you should definitely read in SVG files and do it. Yeah, that would be a great thing to do. So all these things are things hopefully you all as the viewers will watch and be creative. Is there a way to get the circles to sit outside each other? Is there a way to get the circles to, did the camera just go off? Yeah. I don't understand what that means. Oh, to like, well, I mean, I could certainly be more thoughtful about how I'm rendering them. I don't know exactly what you mean about sit outside of each other, but yeah. How to extract points from an image. Yeah, that's a good question. I don't know how to do that. I mean, I think there's a variety of different ways you could do that. Certainly an SVG, in theory, is exactly that. But an SVG is going to have all this information in it about the different kinds of curves and vertices and how the shape is actually constructed. That would be a good topic for another time. I don't know if anybody has any really good suggestions. Try to draw a square. Oh yeah, that's cool. Let's do that. Thank you for like distracting me from that question. Yeah, I think a variety of techniques for doing that. Different code libraries actually will do this for you. Like for example, there's processing used to have this library called Geomertive. I think it still exists, which will extract the path from like a font. I don't know if it does generic SVGs. Processing as an SVG loader into something called a piece shape, and it may have some algorithms in there that then allow you to extract the arbitrary vertices. But yeah, MeIMCB says I also have to do the circle at an even rate. Although I could do also this thing called RDP. RDP algorithm is Rammer-Douglas-Puker. Is that the right name for it? Decimates a curve composed of line segments to a similar curve with fewer points. So this would be also, I should do this as a coding challenge. I need to do this, I need to add this feature to ml5 in the sketch RNN class anyway. Let's try the square. That's pretty interesting to see. But once again, I could feed in. Welcome new member David Snyder. Hello. Thank you. The lights are flashing in my house. By the way, somebody joined in the middle of the night. The lights started flashing last night. Woke me up. I think I'm going to have to turn that off while I'm sleeping. But thank you, whoever joined in the middle of the night last night. Right, it'll be interesting. I mean, one thing that'll be interesting to actually just to do Fourier transform to like the path of like a flocking agent and things. There's so many possibilities here. Let me check the Super Chat membership log. Okay, that's the regular chat. Okay. So thank you, new members: Benjamin Grosser, Ty Smith, Mr. Ugla. Thank you for your sponsorship of me getting the original Book of Random Numbers, and thank you, David Snyder, a new member. What about a star? All right. Okay. This is the point. I make this, and then you can go have fun with it. I don't know if I have the energy for the KNN thing right now. This is kind of cool. There you go. There is the star. All right, what could I do today? So I guess I have to go at 12:30, so there is 45 minutes. I mean, part of me wants to just do multiple, to stay true to my like multiple live streams, one thing per live stream. Like I feel like that took a lot of mental energy to work out, and I'm a little bit drained. I think starting the KNN stuff, that's too big of a project to try to tackle in the next 45 minutes. That needs a whole session. So I could, dare I say, just do like one more of these and load the quick draw data set. People are saying KNN, please. Oh, that makes me sad. Please do KNN. All right. All right. Let's erase this. I'll do a little of the KNN. The KNN stuff, by the way, is covered in the live stream I did at Grow Paris. I could also just sit here and do a dramatic reading of that paper on lattice-Boltzmann flow. Let me make sure all this is saved. I'm going to be uploading this, not to worry. It's going to take a minute for me to set up here. Sign in here. All right, let's try to do the KNN thing today. I did sort of promise it, and so I need to do the two-factor thing. Sort of like a security thing. I mean, these authentication codes come and go. I can't imagine there's a reason for me to worry about typing it in here. Pretty sure we haven't updated the reference yet. Let me check. Yeah, KNN is not on here. So let me... Where's the ml5 stuff? looking for where I last left off. This is going to go in the beginner's guide to machine learning. I don't think this will be a coding challenge. And I'm just looking for where that stuff. I don't really. It's fine. I don't need it. I just was curious. So let's make directory KNN. And let me just grab. This is good to grab. And then I think is current version. I'm just getting myself ready with some starting code. I am just getting some. I want to start with base code that already has the video in it. Why is this not formatting? That's weird. Why is my code formatting not working on save? Let's see what we've got going here. Oops. Missing initializer sketch line 1. Okay, hold on. Yeah, okay. Hold on, why? First of all, there's a 7.3 of P5 now. Oh, I can't do it that way if it's going to be a global variable. Okay. Okay, so that's working. Sorry, hold on. I just want to start. This is going to go in, just so you know where this is going. This is going in. Is it not even here? I don't have that as a shelf anywhere on my homepage. Okay, this is going in here. So basically, what I'm about to do will be in this playlist, probably around 8. Prettier extension at the bottom is showing an X, which means that you have a syntax error. That's why it's not formatting. Okay, thank you. So this is going to go, I think, in this playlist. That's why I'm going to start with this base code. Let's see, does this run? Model ready. Oh, so that. Just seeing if this is going to work. Okay, yep. Does this matter? Model ready. Yeah, okay. Great. All right, so so I'm almost ready to start. Well, it's still okay. It's 11:50. And then, what was I going to say? What else do I need? Oh yeah, why is my prettier not working? Oh, now it is working. Oh, there was just some error. But I want single quotes. I don't really care. All right, I'm not gonna worry about this. Okay, I'm gonna. Oh, it's double quoting it automatically. That's fine. I don't care. I don't care. All right. Okay. Okay. Please hold. Test 1, 2. How's my microphone doing? 2 bars. 2 bars. All right. All right. Question. How do you say this word? How do you pronounce logits? Logits? How do you say it? What is it short for something? Define logits. The logit function. Okay, logit. Logit. Still have a bit of a cold. Can I hear it? No. Logit, it would seem. The log odds. The logarithm of the odds. Interesting. Okay. Logits. Like logics? Here it says low. Look, that specifically says logit. Half an hour later.
Lodgets. Lodgets. Lodgets.
It can't possibly be wrong because it's on YouTube. Put it on Google Translate. That's an interesting idea.
Log it. Log it.
I don't think that's right.
Logits. Logits.
What if I want it to be in French?
Logit.
Yeah, I like that better.
Logit.
I don't know. Logit. Nobody knows. Nobody knows. Nobody knows. Nobody knows how to pronounce this word. Machine learning pronounce logits. Pronunciation. Low. That's low. This would be low. Low, right? Logit. Logit. I'm sorry, but I cannot possibly teach KNN classification because I have no idea how to pronounce logit. Logit? Logit. All right, I'm going to just go with logit because that's what it says. Let's just try one more. Economic job rumors. Ugh. No, I don't want. Ugh, I don't want like all this stuff. Oh, they tricked me. Look, they got me with the Start Now button. Oh yeah.
Logit regression.
Logit regression.
Logit regression. Logit regression.
I guess it's logit. Seems to be logit.
Logit regression. Logit regression.
Logit regression.
Logit regression.
Logit regression.
A lot of logits. All right. I'm putting that aside now. I've got like a logit. All right. Good point. Bruno says wrong pronunciation equals more comments correcting you, more video relevance for the YouTube algorithm. Okay. So I'm going to basically okay. Oh, this is not using KNN classification. Oh, how annoying. That's fine. That's funny. This is using the other way of transfer learning. That's fine. So we will keep the teachable machine up.
This is an experiment that lets...
Okay. Now, do you hear that weird sound? There's like a weird high-pitched sound. Logis. Okay, now. Okay, great. I am ready. We're going to begin this video. Logit, 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 logit. I'm going to say logit. Okay. All right. I'm not really super prepared, but let's do this anyway. Oops, this camera is off apparently. Hello? Oh, whiteboard camera went out. That's not a good sign. Oh dear. Oh, there we go. Okay. Okay. Hello, I am back in the Beginner's Guide to Machine Learning with ML5, and today I am continuing this series, and I'm going to do a few videos about something called KNN Classification. And the thing that I'm going to use it and apply it to is building your own teachable machine. Now this is the Teachable Machine project from Google Creative Lab, demonstrating this idea of transfer learning, taking a pre-trained model and using it as a foundation to train a new model on top of. Now you might be thinking, like, didn't you already make these videos? There was that whole thing with the feature extractor and classification and regression and saving the model. Yes, you are right. I did already make those videos. However, I'm going to basically do the exact same thing again, but with a slightly different technique, and that technique is called KNN Classification, which has some advantages. There are pros and cons to both of these techniques, and at the end maybe we can sort of wrap up and look at why you might pick one over the other. But the main advantage, one of the main advantages of KNN Classification is it's sort of training the model is happening as you're adding new images as opposed to a separate step, and I'll get into why that is in a bit. So this is the Teachable Machine project. You can go to teachablemachinewithgoogle.com. And what I'm going to do is I've already trained this, and so if I'm just standing here in the middle, I've trained it to know of just me standing here with kind of like a angry look on my face that's orange, my hand to the left as green, my hand to the right as purple. So what I want to do is emphasize that what you can actually do is build a gesture-based controller for some type of game using this technique. Now, you could do this with the other way as well, but it's not something, I really looked at it as just a new way to like classify new images. But here, let's think about it. If I'm training a model in real time to understand that my hand is holding up on my left and my hand is holding up on my right, or I have no hands up at all, you could imagine I could control a character, a pong paddle, to move left or right, or maybe up or down. So that's what I'm going to do. It's going to take a few videos. There's a bunch of things to get through, but that's the idea. All right, so you can play around with this website to get a sense of, this is a really nice interface. There's a ML5 version of this. This is built with TensorFlow.js, ML5, which is a library built on top of TensorFlow.js. We have a similar version. All of this work was done by, sorry, I'm in the wrong place. All of this work was done by Yining Shi for ML5, and Yining Shi has been teaching a class called Machine Learning for the Web at ITP NYU. Thank you so much to Yining for allowing me to be inspired by and use your materials in these tutorials. Hopefully Yining will come and be a guest again on the Coding Train and show some additional examples of things you can do with KNN classification. And I would highly recommend you look through this syllabus and examples, and there's also a whole presentation about KNN classification. That's Yining's slides that you could look at. But what I'm going to actually follow is this article written by Nikhil Thorat, who is one of the creators of TensorFlow.js, one of the members of the research team at Google. Google Brain developing TensorFlow.js. You can see here, and this is a notebook about how all of this stuff works, and I'm going to basically go through this, but not use the code here. The code that's provided here, if there is any code. Wait, hold on. Yes, sorry. Mathieu, you can do a nice little edit there. I'm not going to use this code, which is kind of the raw TensorFlow.js code. I encourage you to look at it and think about how it works. And this might be a place where you actually want to get more lower level into it. But I'm going to use the new ml5 KNN classifier feature that is in the ml5 library. Now, this feature is only in the, you're going to want to make sure you're using at least version 0.2.1 of ml5. So as of version 0.2.1, the KNN classifier is part of ml5. But I will mention at the time of this recording, the documentation is not yet up on the website. But hopefully by the time this video is released as part of that playlist, you will find the documentation on the website ml5js.org. All right, so now. So let's do this. Okay. Slide URL. Okay. All right, so let's start going through this article, and let's start right here at this moment of background, MobileNet. Now this is MobileNet. The MobileNet model is something that I've used in just about almost every video up until this point. So if you've been watching the playlist, you're somewhat familiar to it. MobileNet, this is our first step, load MobileNet. And MobileNet is a machine learning image classification model that's been trained to recognize 1,000 classes of images. And it was trained based on a huge database of images known as ImageNet. This is typically, I've said this before, but this is a database that exists for researchers to use and try to develop machine learning algorithms with, but it's not necessarily a model that's just works particularly well in kind of like generic applications of image classification out in the world, because it knows a lot about birds and dogs, but not about a lot of other stuff that appears in the world. However, it is a good basis to load. The first step one is to load this model. It's a good basis from which to do this feature extraction process, this transfer learning process, which we did before and we're going to do now in a different way. So the next step is to then create what's called a feature extractor. So this, I'm going to show you in the code. This is actually basically what I've done before. So this is what MobileNet does here. You can see it can look at an image. It can tell you what the probability of a particular class, like Egyptian cat, tabby cat, tiger cat, remote control. Apparently, there is a almost 2% chance it's a remote control. Okay. Cat, you are not a remote control to me. All right, so now what I have already, which is basically from my previous examples, is and let me just clear that out. What I have already, which is basically from my previous examples, is a sketch that loads the image from the webcam and displays it in the window. And I also, like I said, have a reference to the ml5 library, and I also have this feature extractor loaded. So I'm using P5. I'm connecting to the webcam, using the P5 library to connect to the webcam and draw the webcam's image. And then I'm using ML5 to create a feature extractor with the MobileNet model. So now we can go back to Nikhil's article and scroll down and be like, okay, so this is the end result, the cat softmax. So what does this mean? So the MobileNet model is a neural network that expects an input of an image. that image comes in and it's processed over a variety of different layers. So the image is like transformed and processed and twisted and turned, and all of that is the neural network process, which you'd have to refer to some of my other videos and other reference materials to understand about how this works underneath the hood. But by the end, what it gets is a big vector, a big list of numbers that are all probabilities. They all add up to 100%. And if you look at that here, that's what we're seeing here. And we're seeing all the way over here, like these classes have a very high probability. So somewhere in here, we're getting this like number, like 0.9, maybe we're getting 0.7, maybe we're getting 0.05, and all sorts of other numbers, they add up to 100, and 0.9 is probably, this particular number is the number that corresponds to the probability of it being an Egyptian cat. So this is what MobileNet would do on its own. But this stage is called the softmax stage. Softmax is a fancy term for normalizing the output of all of this process to a set of probability values that all add up to 100%. But there are stages before. One stage before, the stage before is called the logits. And I spent by the way, before I recorded this video, I spent like a half an hour trying to figure out how to pronounce it, whether it's logits or logits. And a lot of places said logits, and some other places said logits. I'm gonna go with logits, like logic or logical. But you can see, this is actually what the logits look like. It is the unnormalized, the non-normalized output of the neural network. It is a layer. I shouldn't be using my hand. I have an eraser. It is the layer right before. This is called the logits. And it's just like a lot of numbers. Who knows? It's probably normalized within some type of range, actually. But it's a whole lot of numbers. And softmax is applied to get this last output, which is good for classification. But this layer, all of these numbers, this is referred to as the features. I know I explained this in a previous video, but in case this is useful to sort of give this another try. And it's kind of, again, we haven't really gotten to, the next step is where something pretty different is going to happen. This is still the same as before. And so we can look at it. This is what those cat logits look like. And you can notice there's peaks still around here, but there's lots of other stuff going on. And you can see Nikhil writes, this is a semantic fingerprint of the image. Right? This is basically the essence of the image, the boiled down numerical essence of the image as perceived by the MobileNet model. So because an image itself, right, let's say this image, I forget what the dimensions MobileNet requires is like maybe 224 by 224 pixels. This is like a lot of numbers. So you could say this is the literal numeric representation of the image, is all of the RGB values of every single pixel. But that's too many numbers to work with and compare and try to make sense of the image. So this pre-trained model has already learned how to boil it down to just 1,000 numbers. And if we have 1,000 numbers, we can start to compare this image to, let's say, another image. So this is the feature extraction, getting these features, that essence, the semantic, what did Nikhil write? Semantic fingerprint of the image. If I have two semantic fingerprints of two images that are arrays of numbers, there's lots of math that I could start to apply to them. I could say, well, how similar are they? Well, how similar are they compared to these other images? Or what if I were to sort of like interpolate between one image to another? And you've seen some of these maybe like artistic visualizations of the output of neural networks as like moving through, you might hear like walking through the latent space. So this idea of like interpolating between the features of images to generate something. All of this is interrelated. But here, this now finally is the moment where I can say, this is how it relates to KNN classification. Because KNN stands for K nearest neighbors. So if we get the logits for an image, I could say, well, what other images have I seen previously that this semantic fingerprint is very similar to? Then this image is within that category of those images. That's K nearest neighbor. So I'm going to wrap this up and we're going to start implementing the code in the next video. But let's take one more step. Let's actually look and see with ml5 how easy it is to get those logits. So I'm going to come back over here and I am going to, so this is my code, right? So in my code I have the video and I have a feature extractor. The feature extractor, I'm just calling it features, is preloaded with the MobileNet model. So now what I'm going to do is I'm just going to say, I'm just going to add mouse pressed, which is not what I'm going to want to do ultimately. And I'm going to say features.infer video. So the infer function is the naming. I'm a little unsure about this naming, but it's what the, maybe it'll change in the API at some point. But this is the idea of inferring the logits from this particular image. So this could be a static image, but since I have the video, it's whatever the snapshot of the video is right now. And this could go into the logits. This is basically giving me that particular logits. And I'm going to do something here that's going to look weird. I'm going to say console log logits. Like, shouldn't that show me just an array of numbers? Not exactly, but I'm going to show it to you. Let's see what happens. So let me refresh this. Okay, the model is loaded. Now I'm going to click, and you see, what? What? Well, this looks kind of D-type, float 32. Okay, floating point numbers. There's 1,000 of them. What's all this nonsense? Look at all this. This looks crazy. Well, guess what? We just waded by accident, or kind of on purpose, since I did it on purpose, into tf.js territory. Now, to continue writing this code, we don't ever have to look at the TensorFlow.js documentation, but this is a moment to realize like ml5 isn't some magical thing that exists on its own. It is operating on top of TensorFlow.js, meaning it's managing something called the tensors for you. What's a tensor? A tensor is basically a fancy word for an array of numbers or a matrix of numbers. And so the logits are a tensor. It's a one-dimensional array of all those numbers, so they are actually a tensor. I can actually look at those values in the console by saying logits. I can actually say logits.print. So let me do that now. And if I click here now, you're going to see there it is. Now, it's not printing it all out, but you can see like, oh, that looks like an array of numbers. And another way I could do it is I could say console.log logits data sync. So data sync is a function. These are functions that are part of TensorFlow.js, and you can go back and look at my TensorFlow.js videos as background where I go through them this more specifically. This is a function that gives me that data as a regular array. So last step here would be to do this. Click, and there you go. This is these are the logits. This is the digital fingerprint of that image. So we are now ready. We now, hopefully, from watching this video, you understand maybe a little bit about what KNN classification might be, but that's what I'm going to get into. That you're loading MobileNet, the pre-trained model. You're creating a feature extractor which knows how to pull out the logits of the MobileNet model with a given input image. And then we're passing in an image from a video, and instead of getting the classification, getting just that digital fingerprint. And that semantic digital fingerprint, this is exactly what we're going to do in the next video to train a model, a KNN classification model. All right, so if you want to keep watching, then keep going in this playlist. If the video doesn't exist yet, it's because I'm still working on it, but it'll be there soon. Bye. Okay, wait a second. So how many horrible mistakes did I make? I guess I've been, looks like from Go Faster, Dan. All right, I like to explain things. We can edit it down. It is 12:20. Let's see if I can finish this today. So I think I was kind of conflating, I think I was being loosey-goosey, I guess. Maybe I'll mention this at the beginning with my kind of, oh, it's an array, it's a vector, it's a tensor. Technically speaking, and maybe I'll mention this when I start the name. A tensor is an n-dimensional, I don't know if array is the right way, but like an n-dimensional set of numbers. What did Simon write? N-dimensional thing, right? Not really an array. It's an n-dimensional collection of numbers. Whereas an array is an array, a list of things in code. So these are similar concepts, but there's some nuance there. Tensor is a much more sort of like generic term for this idea. Okay. They are tuples, not vectors. Okay. Let me just look up the definition of a tensor. No, not TensorFlow. What can I say besides thing? Yeah. Oh my God. Could we possibly write this in a more confusing way? Tensor is a geometric, but I mean, it is accurate. It's what a nice. Yeah. I think I don't need to get into the detail of this. So, but I will mention something. I will mention that. Okay. All right. We are ready to do the KNN classification. Right. Matrix. Okay. Thank you. That is actually a very good point. Scalar is. Yeah. N dimensions. Thank you. Simon's writing some very helpful things here in the chat. Okay. Construct. All right. Thank you to new member Sarab Kumar. Hello. What am I doing? I am looking for, hold on. I'm looking for France. I just want to, since I don't have the ml5 reference to look up, I have my code from the workshop in France that I'm just pulling up over here in case I need to look up the names of any functions. Where was that? I don't remember where I put that. Is it in Schiffman? GitHub Schiffman? I'm sorry, I'm looking on the invisible computer. Repositories. LeTank workshop, yep. So I'm looking at github.com/Schiffman/LeTank workshop because the code is let me look at the final sketch example. I don't remember where all the functions are named. Classify, load, classify, features, KNN classifier. Okay. KNN add example. Okay, great. Okay. Okay. All right. Whoops. Oh, because I did it before the model was ready. Okay. Okay. All right, we are ready to continue our ML5 KNN classification, what I'm calling game controller. I want to be able to create an interface by which I can train a little controller for a game to move something left and right, maybe up and down. That's what I'm doing. Now, in the last video, I left off at this step where I load the MobileNet model, I create a feature extractor, I pass in an image from the webcam, and I get the logits out. So one thing I do want to mention, people in the chat were helpful. I was being a little bit loosey-goosey with the terminology of like scalar, vector, matrix, and tensor. And so I should mention that a scalar, right, being like a single number, is really 0 dimensions. A vector is typically like a list of numbers, which is really one-dimensional. A matrix is thought of as a grid of numbers. This is 2D. And a tensor is a term to describe the sort of n-dimensional possibilities of any collection of numbers. So a tensor can be 0 dimensions, 1 dimensions, 2 dimensions, 3, etc. So that's what those terms mean. And in this case, the logits come out as a one-dimensional tensor. And the shape of it, the dimensions might actually be something different underneath the hood in TensorFlow.js, but that's one way of thinking about it. So hopefully that helps clarify a little bit. But let's now move on. And I'm going to, the next thing that we're going to do is we're just only going to work from assuming that we have the logits. And the algorithm, we don't have to write ourselves. I think I have a video where I do some kind of KNN, writing the algorithm out. Maybe it was for like movie recommendations or something. I'll try to reference that in the video's description. But the next thing we need to do, and I don't remember what step I was on, it's like 4, is create an ML5 KNN model. It's going to be an empty. It's going to be create an empty one. So I'll explain what that means in a second, but this is an empty one. So the way that I do that, I'm going to go back to the code, is I'm going to say, I'm going to make another variable, I'm going to call it KNN, and then in setup, I'm also going to say KNN equals ML5 KNN classifier. I think that's how I write it. Let's see if that works. And then if I look at it here, this looks good. Looks like I've got one. I've got some functions. Oh, hold on. Timeout. Wait, this isn't right. Timeout for a second here. This is not with the new names. Oh. This is weird. There's no ML5, right? Okay. Hold on a sec. Apologies. I'm not seeing the right names for the functions, I don't think. So what I'm looking for is in the source, KNN classifier, index, add example, classify, clear label, clear all labels. And yet, what I see here is clear all classes, clear class. I might have to get my pre-built version of the library. Wait, but I tested this the other day. All right, let me explain what's going on here. We recently did a release of the ML5 library, and I thought it had these new names for the functions in it, but npm.js ML5, I'm not seeing the new names. Let me go to versions, right? That's the latest. I could just build the library myself, but I did reference saying you had to have 0.2.1. I'm waiting for somebody to, it's 12:30. I know. I have a little more time. I'm waiting for somebody to figure this out for me, but like nobody is, so I have to figure this out myself. So when I did, this is weird. When I did the workshop in France, I had, let me download this. Oh no, hold on. Sorry, when I did the workshop in France, where's Latank? What I'm going to do is go to KNN image example. Let me just do the sketch we created in the live stream, which has all the stuff that I want to do and save. Okay, so I'm going to do download. Okay, and then I am going to, weird, I already downloaded this. What a different one. I'm going to extract it. I'm going to put it on the desktop. And I'm going to, what is going on with my, let's see if this works. Whoa. Something is going wrong here. I think I know what that problem is. Sorry, everybody. I had a little. We've had. Oh, why is this not? A little bit of an issue here. There's actually a mistake in this code, which I can fix. I just realized, which is this should not, KNN loaded. This I should not be doing until the model is ready. Okay. So this is where I can't remember what the classes were, but this is, in that example, this is working. And now, if I go to here, let me just get these things. So instead of using, let's use this local ml5. Does this still work? That still works. Now let me use ml5 2.1. Oh, it works. What? Hold on. Where's... It still has the wrong function names here. Am I just looking in the wrong place? I'm like losing my mind here. This is so weird. So wait, this is working? Yeah, it's getting clear labels. That's fine. It should have an error now. That worked, though. Huh. But clear all classes is not a function. But if... Oh! Oh, I'm losing... Oh, I'm so silly. Oh, I was wasted so much time. I get it. I get it. I get it. Oh, I'm so silly. Everything was fine all along. I overthought it. Let me now explain to you what my problem was. So, this is the KNN object that we're working with. Here are all of the functions I was looking for. Get count, get classifier dataset, clear, live, save, load. These are the functions I'm looking for. Those are the functions I'm looking for. I went to here and started looking at these functions. Guess what? These are all the TensorFlow.js native functions. And they have like some slightly different naming and some more stuff. Clear, train, dataset, matrix. I was just completely looking in the wrong place. Everything is fine. Sorry for wasting your time there. I have no idea where I was, but I will figure that out. We'll close this. I don't need this Latank workshop one open anymore. Which one? I don't need this one open anymore. I was in the code here, and I was here. Ah. Let's see if I can get a little further. Try to at least finish this. Does anybody remember what I was doing? Does anybody remember what I was doing before I got lost in that? I think I was over here, and I had said create an empty ml5 KNN model. So I walked over here, and this was me creating the empty one. Okay. So let me just do that again, because I don't know, I went off the rails there. So let me minimize this, do this, this. Okay, sorry everybody. And I can close this out, leave that, okay. All right. So something create an empty ml5 KNN model. Wow, that was loud. Okay. Something created empty ml5 model. Okay. Now, where do I want to do that? So I have my video, I have my feature extractor, and now, oh, sorry. I have to pee. I also have to go soon. Something created ml5 model. So I'm going to add a new variable, KNN, and then in setup also, and I may have to move this somewhere else eventually, but for right now, I'm going to say KNN is a new ml5 KNN classifier. Simple as that. So I have the feature extractor and the classifier. I think it's time to talk about what is KNN classification. Luckily for us, we can refer back to Nikhil's article. Thank you again to Nikhil for publishing this. and I'm going to skip through some of this more examples of different logits, and I'm going to look down here and look at this. So this is a nice example demonstrating the idea of k nearest neighbors. So let's sort of recreate that visualization over here on the board so I can talk through it a little bit. Let's say this is a two-dimensional space. It is. And I'm going to put in this two-dimensional space a bunch of A's and a bunch of B's. Now, I've written them in a kind of certain way to make it very obvious. In fact, if I wanted to, I could draw, just visually, I could sort of understand where's the quote-unquote decision boundary between these two different categories. And I could kind of draw like this. That's just me eyeballing it. I'm not sure if that's exactly the sort of exact mathematical decision boundary. And then I could say like, oh, if I threw a dart at the wall, the dart's either going to be like over here or it's going to be over here. It's going to be either of class A or of class B. It's going to be either, I want to classify it. Now the way that k nearest neighbor works, the n stands for nearest, the n stands for neighbor, the k stands for how many nearest neighbors am I looking for. So the way that it actually works, the way that the decision boundary is computed, let's take it out for a second, is that if I were to look at any given point, like this one, let's say I have a k of 3, and typical you would want a k that's an odd number, because what you want to do is it's basically like a voting system. I want to look for the 3 nearest neighbors. And in this thing, I mean literally nearest. The Euclidean distance, by proximity in two-dimensional space, which are the nearest? Well, I can eyeball it. I could say, this is the nearest, this is the nearest, and this is the nearest. So these are my 3 nearest neighbors. They all vote, and 3 to 0, this spot gets categorized as an A. We could get a little more complex, like what if I went over here? I could say, what are the 3 nearest neighbors? Well, this is the nearest, this is the nearest, and this is the nearest. By a vote of 2 to 1, actually this k being odd is actually irrelevant because you can have more than 2 classes. So breaking the tie is a thing. But here, I could say by a vote of 2 to 1, this point is classified as a B. And this is exactly what Nikhil's visualization is doing. And in fact, this would be nice to actually do a coding challenge of just like doing exactly this, like remaking this visual explanation. But what I can do here is I can vary this. Like I can say, let's look at a 3-class example. Let's make k much larger, like 8. And we can see here, this is showing what category it is. Hold on, close this, make this a little smaller. So I can see it. And I could also show that decision boundary. And you can see here, this is the decision boundary. So this is the idea of k nearest neighbor. Wait, so that might make sense to you. You might be thinking to yourself, what? Wait, suddenly you've got this like two-dimensional graph and a bunch of points, which ones are near each other. What does that have to do with images of cats and logits of 1,000? Well, it does. It has something very specific to do with it. In fact, the reason why Nikhil picked that example in his write-up, and the reason why I'm drawing it this way to explain it to you, is because our brains are very well suited to think in small amounts of dimensions. 2 dimensions, 3 dimensions. So you could think of each one of these points in two-dimensional space as the logits that just has 2 values. It's x and y coordinate. But what the feature extractor does, so I'm going to say like infer from an image, right? Remember this step from the previous video. This gives us 1,000 logits, a list of 1,000 numbers. And I said, like, what if we got 2 of them, 2 lists of 1,000 numbers? How could we compute it's the distance between these 2 things? Like, it's weird to think about, how do I think about the distance between 2 things in a 1,000-dimensional space? Well, actually, the formula that you would use for Euclidean distance in two-dimensional space is the same exact formula that you would use in a 1,000-dimensional space. Beyond the scope of this video, I could make another video. Maybe, it's basically looks like the square root of the difference between all the values squared added together. It's like the Pythagorean theorem. But actually, this Euclidean distance formula is not such a good one for higher dimensional spaces. It kind of breaks down because you could have a lot of the numbers similar, but just one number really far away from another one. So there is actually other ways of calculating distances, one of which is called cosine similarity or cosine distance. And actually, I've referenced that in my word-to-vec tutorials as well. This comes up exactly in the word-to-vec stuff. And this is a way of looking at, you could think almost as if I wanted to compare A and B, I might look at the angle between them, right? If this is the origin, right, and I'm looking at these 2 points in 2D space, is there a small angle between them? That's kind of like what cosine similarity is doing, but what's that sort of like angle between in a 1,000-dimensional space? But the point is, if I can infer the logits from an image, I can build up a database of, let's say, cat. I can then use the, what I'm going to do is use the add example function. So ml5 has an add example function that I give the logits and the label. So I can basically build up a database of a lot of logits labeled with cat and store them so that later when I get a new one, I could see where is this new one in 1,000-dimensional space near all those cat ones? This is exactly what we're going to do. So in other words, let's come back here. And I'm going to say under mouse press now, instead of console logging it out, I'm going to say KNN add example cat. And actually what I'm going to do is I'm going to add left and right. I'm going to try to do left and right because the idea is I want to control something. So I'm going to have an example. These logits are categorized as left. And I'm going to change this to key pressed. This is sort of silly what I'm doing, but I'm going to say if key equals, I forget how I do the arrow. If key equals L, again, I should be building a nice interface for this, but this is going to just do the trick. Right. So what I'm doing now is I can now build up that database. This is the model. The KNN model is actually just the big database of all of the logits that are labeled. All right. So the idea here is that I extract the features from the video. When I press L, I'm saying like this is one to the left, and when I press R, this is one to the right. Let's take a look at that. Go back here. But click in here to give it focus. So I want, this is confusing because it's not mirrored. This is my left. You see it as my right. This is my left hand. So I'm going to use my actual left. And I'm going to press L. So I'm training it. And then I'm going to do this and press R a bunch of times. Now, of course, I shouldn't be console logging to see what's happening. But I at least can look now at that KNN object. And I can look in it and see what are some functions I can call. I can do get number of labels. Two, right? Left and right. I could also probably like how many examples are there, but this is me training it. Sorry, I didn't mean for that to come up. Edit that part out. Okay. Thinking. We're actually not too far. We're not too far from being done. Oh! Two labels. Oh, and look. Left and right. I didn't even notice that. Map string to index, that's there. Okay. So now let's think. So now what do I do? Let's use mouse pressed. Let's go back and use mouse pressed. What if I get something new and I want to classify it? Aha! So let's say this is me training it. Like here's a bunch of lefts, here's a bunch of rights. And when I click the mouse, I want to see what it is currently. So what I'm going to do now is I'm also going to infer the logits from the video. Then I'm going to say KNN classify those logits. Ah, here's the thing. This is where I now need a callback. So everything so far I've been able to do synchronously, like I can pull out the logits, I can train it, but this is now the computer, the ml5 library in TensorFlow.js, but needs to like do something for a little bit and let me know when it's done. So I am going to add a function called getResult, and I'll just write a separate function. Again, I'm doing this in a very sort of like ES5 callback kind of way. You can use promises and all of that as well if you prefer that. But I'm going to say getResult result, and I'm just going to say console log result to just see what that looks like. So now I press keys to train it, and you know it would be nice for me to console log something. So console log left, just so I see that it's working. Console log right. So I just console log something there. Again, if you were doing this, you probably want to build a whole interface for this. I'm doing everything with just key presses and console logs, which is super awkward in terms of like user interaction, but allows me to test and iterate and explain this idea more quickly. All right, so now refresh. So what I want to do is, and by the way, I'm going to get an error. So, KNN classify is not a function. Why? Well, oh, I spelled it wrong. Classify. So here's the thing. I want to say like if I only want to do this if it's ready to classify. So I want to say if KNN, what was it? What did I say? KNN get count or get number of labels or something. I'm going to say if KNN get number of labels is greater than 0, then actually do the classification. Pause for a second. I'm going to just turn off the sound there. Okay. Okay, here we go. All right, so now let me refresh. And I'm going to click over here and train it left. Here's like 20 images, train it right. Here's 20 images. It's not 20, it's 17, it's 21. Now, I'm going to click the mouse. I know what I did wrong. I always do this wrong. ML5 uses error first callbacks. P5 doesn't. And so I'm so used to just the result being the first thing. But the error, and any error always comes in as the first argument to the callback. So I'd want to say if error, console. I probably want to handle, there's many ways I could actually handle the error. Otherwise, console log result. I got to do this again. It's fine. Here we go. Okay. So I'm going to train it. Wait, no, whoops. 21. I'm going to try to do about the same amount. 22. Now, please say left. Look at that, left. Please say right. Oh, no, oops, I clicked in the wrong place. No, right, it said right anyway. Right. Left. It's working. Oh, that's exciting. So we've done it now. This is basically it, right? And I could, just so you know, by the way, I could say, let's add one more. Let's call it up. One of the advantages of doing KNN, like I was saying, this KNN classification, unlike the other feature extractor with transfer learning example that I went through previously, this requires no separate training step. The model is just the database of training images, and it's able to do that distance calculation in real time. So also, I can add labels later, I can add new images later. So you can kind of like train and classify all at the same time in a very flexible way. That's one of the advantages of doing it this KNN classification way. All right, let's do one more thing, which is, let's actually just have it constantly try to guess. So I'm going to make a label paragraph. I'm going to say label paragraph equals create P, need training data. Then what I'm going to do is, let's just make sure that's working. So it says need training data there. Then what I want to do is, I'm going to have a Boolean variable called ready, have it be false. And then in draw, right? Whoops. What did I do? Sorry, everybody. I want this. Basically, since draw is looping anyway, there's a more elegant way I could do this. As long as it's not ready, and if it's not ready and there's at least one label, I can start. So I can start this classification, and I can now say ready is true. And then in the classification, I can, when I get the result, what do the results look like? They have a class index, confidence is by label, and the actual label. So I can get the label, I can say label p 8.html, result.label, and then guess what I can do right then? I can classify again. I probably want to break this out into a function, but I'm just going to copy paste the code right here. Whoops. This video was going very well a moment ago. Well as I could have expected. Okay, and I don't need this anymore. No, that's not right. This is what I want to do. These 2 lines of code. What do I want to do? Let's put this in another function. Go classify. I mean, I could think of a better name for this. And actually, let's take this. I'm going to do this. I'm going to make this a little nicer. I'm going to do go classify there. So if this is true, then go classify. A little refactoring, because why not? This callback is a little silly to have it as a separate function. Let's just make this an anonymous function and put it in right here. So this is maybe a little, so this is what I'm doing. I'm basically saying classify. What does classify do? It gets the logits, it calls classify with the logits, then it has a callback, it either gives an error, it labels it, and then guess what it does? Go classify again. So this is kind of this recursive, just like classify it when you're done, classify again, when you're done, classify again. Okay, let's see here. Needs training data. So let me do this. I'm going to give it some left. Whoops, got to click over here. So it's only going to ever be able to classify anything as left right now. And at some point, it knows that it's right. Left, right, left. Okay, let's train it better. First of all, one thing that's bothering me is it's very hard to see that. So style, font size. Is this how CSS works? With P5? Dude, too big. Okay, let's try this one more time. Here we go, everybody. Ooh, that's so loud. Give it lots and lots of examples of me with my hand to my left, about 50 of them. Now let's give it lots and lots of examples of me with my hand to the right. Maybe, okay, now. Left, right, left, right, left, right, left. Give me the hand, left, right, down. I gotta stop. Okay, so, this is good. So guess what? We're kind of there. I mean, there's a lot of stuff. What's missing here? Well, first of all, I want this to actually be able to control something, like moving a paddle left and right. And then also, I might not want to have to train it every time. Now, I think there's interesting, probably a lot of really unique applications for you to make something that the user is actually expected to train their own controller. There's a TensorFlow.js examples, has an example of training your own controller to control Pac-Man. I'll link to that in this video's description. But in this case, what I might like to show you is that I could sit here and train it for a while, save that, and load that model into like a different sketch, which is just doing the classification to move something. So that's what I'll do in the very last video, and I'll add up as well. So the last next step that I'm going to do is add saving and loading, as well as a simple game mechanic to control as well. And you probably, the save and load functions are just called that, save and load. And so you might even try this yourself before you watch the next video where I'm going to do it. Okay? Goodbye. I'll see you soon. Okay, is it 1 o'clock? Yeah, so I definitely need to go. let me check my calendar. Sometimes I have more time than I think, because it would be nice to just kind of finish this. Because there's like very little left to do here. Okay, hold on. Now I'm like crazy looking at my email, which I don't want to do. Calendar. Okay, I have a little bit of flexibility here. So much for my short live streams. All right, I want to finish this. I want to finish this. Because there's really very little left to do. Oh, wow, look at that. Let's see if I can do down and up. Let me try, let's just give myself a little bit of time to train it some more. Curious how well it's able to just, so this would be to the right actually, like if my head's on the right of the screen. No, but if I want to move, oh, it's not, I really should, this is really awful. Like, yeah, I'm going to make this to the right because I want to move it. If I move this way, I want it to go to this way. Yeah, okay, no, this will be left. I'm going to use my own, okay, hold on, let me just see. Do I have a, okay, let's see. Just want to see if it will actually train according to just the position of my head. Left, right, up, down. All right, it works pretty well. I mean, the thing is, I'm gonna talk about this. All right, we're gonna finish this off. Okay. Okay. Welcome back. I'm going to finish this ml5 KNN classification example for like a gesture-based controller. So I just, in between the last video and this one, I just sort of trained a quick KNN model where if my head is up here, it registers as up. My head is down here, it registers as down. Over here would be to the left, and over here would be to the right. Now, you know, interestingly enough, because I have a green screen here, and I'm a sort of like quite a different color than the green screen, I could probably just do this with some image processing and like pixel manipulation to sort of like check where my head is. So with a lot of if statements, that's the sort of interesting thing about, like, you can almost think of you doing machine learning as this like automatic if statement, I think is one way of thinking about it. But I also should note that I'm actually almost somewhat surprised that this is working, because you have to remember the image classification model, MobileNet, that this is built on is trained off of like a lot of things like dogs and cats and objects. It really has never seen people. There's no images in its database with like a green screen. So I would have actually expected to actually think all of these images, wherever I am, are kind of similar according to the way it thinks about the world. Whereas if I were to like do this, like that's going to be like remarkably different. So there might be some ways that you could use the sort of the way your understanding of how MobileNet was trained and what kind of images were in there to have other images that are the most distinguishable for it to like learn about. But this is something you probably have to do. You could do through research and you could do through trial and error. Interestingly enough, even if I move the computer around, is it still going to work? Up, down, left, right. So I'm really at a huge advantage here having the green screen, but if you're using this to build some kind of kiosk installation and you have, it doesn't have to be green, but like a fixed background, that's going to allow users to come play with it and have it work pretty well. All right, but the next thing that I need to do, right? So what I want to do is two things in this video. Number one is I want to be able to save it. So I should add that because I spent all this time training it. As soon as I refresh the page, I'm just going to do it. It's gone. All of that training data is gone. So I want to be able to add saving. So let's add that first. And I'm just going to do that. I'm going to keep doing everything in key pressed. If key equals S, I'm going to say knn.save model.json. So I think this is what it is. But basically, everything that it's learned, all of those logits and labels are all sitting in memory, and I can spit them all out into a JSON file. So let's just do that really quickly without a lot of training. So I'm just going to like arbitrarily train a bunch of things up and down. And then let me hit S. And we can see I got this model.json file. There it is. I want to put it in. Pause for a second here. I want to drag it over into my code folder. So I could actually, the other thing that would be interesting to do is let's actually take a look at it. And look at this. Look at this. What's in this craziness? This is it. It's just like lists of numbers. Tons and tons of lists of numbers with the labels. And you might think, oh, this is so much data. Is it going to run so slow? How is it going to do it? But actually, if you look at it, reveal in Finder, I didn't have that many examples, but this is just a, 600 byte file, 600 kilobyte file, about 559 bytes, 559,000 bytes. I don't know why I can't speak anymore. Hold on. Let's Mattia, let's do a little like editing magic here. Let me do that again. Because let's get rid of all this stuff. And let's have, put this here just to make this like a little more elegant in the final video. All right, let me save. Whoops, what just happened? Oh, it was already there. All right, let me save. Oh, shoot. I'm going to get this. I'm going to get this. All right, let me save. All right, let me grab this model.json file. I'm going to just drag it over into my code directory. So now we can see that, oh shoot. One more time. Sequencing is hard. All right, I'm going to press S to save. Then I'm going to go to the download directory. I'm going to grab this model.json file, just drag it into my code folder. I already have one in there because I did this a few times. How is it in there? That's where. It's okay. Oh my God. One more time. This is really silly. I should just like forget all this editing nonsense. I'm spoiled by the possibility of editing now. This used to just be how it was. All right. Deep breath. There's nothing there. Okay. All right, I'm going to click Save. Then I'm going to go to the Downloads directory. You can see I now have a model.json file. I'm going to drag it into my code folder. And then I'm going to go over to Visual Studio Code and take a look at it. There it is. Look, this is actually the saved KNN model. All of this stuff. You can see there's lots of configuration information up here. This is kind of the domain of TensorFlow.js. This is all the stuff that TensorFlow.js needs. We can kind of ignore. But interestingly enough, you can see, like, look at this. It's a whole lot of arrays of how many numbers? I think we're going to get down to 999, 999, 999. Keep going, keep going, keep going, keep going, keep going, keep going, keep going. Wait, what? I don't know how it stores it. Why is it? How does it store it? Forget, I just shouldn't have said anything. Yeah, it stores it in some way. I just assumed there'd be, what are these? Oh, these are all the examples? I'm so confused. I don't know how it stores it. I'm not going to bother trying to explain. Oh, these are the tensors. 0, 1. Oh, because it's all, okay. I'm going to ignore it. Never mind. All right. This is all the domain of TensorFlow.js and configuration stuff that's super interesting. You could go, and we could do a deeper dive into that, but we don't have to worry about that. We can see that all of the numbers of all the logits are all in here. It's just a big file with all of the stuff, all of the logits and all of the labels and the configuration information that TensorFlow.js and ml5 needs. Now, you might be thinking, wow, it's like a lot of stuff in there. You know, how big of a file is that? And actually, it's just text. And it's just 561 kilobytes. So even if I had like hundreds and hundreds and hundreds or thousands of training images, it's going to be fine. You have to remember it's taken an image file, which we work with all the time, and boiling it down to just 1,000 numbers. So even though it is stored ultimately as text, it's much less data. And there are ways of optimizing the storage and all sorts of stuff like that. But ultimately, this is a perfectly reasonable thing to do. So now, let's actually do a better job at training it. Let's actually get a better model to train. So I'm going to hit refresh, and oops. Oh, I lost index.html somehow. Pause, timeout. I deleted that. No wonder. Somebody probably noticed. Oh, I don't have the chat up anymore. I lost my index file. Of course, Simon says I lost my index file. Boy, I'm sorry to make this an editing nightmare, Mathieu. Where's the trash? Let me get that back. Trash, where's index.html? Here it is, this must be it. Interestingly, yeah. Oh, because if I click save or S or something, whatever. All right, let's. All right, we're fresh, and now let's try to train a new model. So I'm going to do, please bear with me. We can speed this up. So let's train 50 up. I'm just picking 50 arbitrarily. 50 down. This is left. And then this is right. All right, I've trained it. Let's see if it's working pretty well. Right, left, down, up. That left wasn't super great. Let's see. But I just not give it enough time. Let's give it some more training. Move around here some more. See if we can make that more accurate. Left, right, down, up. So I'm sure we could do things to improve the accuracy. That's good enough. I'm going to click S for save. Oh, what? S? What? Network error. Oh, that's sad. Wait, why is this not working? What is going on? What? No, why am I getting a network error now? The definition of insanity is doing the same thing over and over again and expecting a different result. Oh, I don't have to refresh. I have to. Now it worked. Thank you very much. All right. Let's go through this again. Now we can train our model, and we'll speed this up for you so you don't have to watch the whole thing. Oh, that's to the right. All right. We'll train our model, and I'll speed this up for you so you don't have to watch the whole thing. This way is to the left. We move around a lot over here. Left, 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 left. Move over here. Right, 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 right. All right, we've trained it. Let's see how it's performing. Left, ooh, it's a little not super accurate over here. Oh, left. Oh, if I go off, interesting. But if I stay here, left, right, down, up. Let's give it some more training over to the left where I'm like off a little bit. So that'll help clean that up. It's a little more accurate now. Down, up, to the right. Okay, now let's save it. I did all that time training it. Please work. What am I doing wrong? Is it like too big? Is it like too much data? It's just like, it must just be like too much. This is a bug, but where can I find the bug? Like there's warnings. Well, it would be in like the network. This is so weird. All right, I'm just going to try doing it with less data. Is it because there's 4? It shouldn't be that there's 4. All right, left. It works. Like, is it just that it's too much stuff? Save it from the console. That's a good point. So I was getting about 200 examples by doing about 50 of each. I think we found a bug in ml5. Yeah. So I think there's a limit. What is that limit? This is definitely a bug. Always good to find the bugs. I mean, yeah, oh, 60. It failed at 60? That works. 20 is fine. 30 is fine. 40 is fine. 50 is fine. 60 fails. Is it a specific number? There shouldn't be a limit. So why I wish I could debug this and get like an actual error in ml5. So, and I assume if I do this, same thing. It's so weird. I don't know if anyone's following along. Is this something that's weird on my browser or computer? Well, I may not be able to finish this today if I can't figure this out. I guess, like, does it really work with like 59? So why would that be the limit? So 51. Oh, whoops. 51 works, 52 works. Oh, wait. I don't know how many it is. Yeah, as soon as I got to 57 or something, it failed. So people in the chat, it takes a finite time to save. You may be trying to save while another file operation is going. So this has got to be a bug in the ml5 library. What is it actually triggering? Is there a save like in tf.js, or we're doing it ourselves? Let's go look at the ml5 library. Shoot. Source. KNN classifier. Let's look at save. Yeah, what could possibly get classifier data set? It's mapping it to with the labels. Data sync. An IO save file. Oh, the IO is like a ml5 utility, so the bug could be in there. This is pretty weird for sure. I don't understand. This is a weird way to save a file, but I guess that's how you do it. All right, maybe what I'm going to try to do, let's bring this code into my thing. See if I can discover what it is. Oh, I really have to go soon. I really want to finish this though. Oh, no. I'm going to hide this stuff down here. Just going to Okay, so now I have my own save function. Let's see if this works. Where's S? Can you try to print the model to the console? I could. Oh, could it be the memory? Just like the memory of the browser is full? Like it's just like my session has like gone crazy? All right, somehow I doubt that, but let's try it. Let me just completely restart the browser. If that's really the case, I'm going to laugh. Let me go up to 60. No, it failed still. So I don't think it's a... oh, whoops. That was weird. Okay, let me try my own save function. Okay, that works. Does this look like it's the same? Does it look correct? Oh, interesting. I did something wrong in my save function. Oh, I'm not going to be able to solve this, am I? I mean, I am going to be, I can solve this, but like doing it right now is a little bit crazy. I missed something here. Is there still a this in here? Oh. That was weird. That's weird. Oh, it's not actually using it. What's going on? This is not happening. Now I'm really losing my mind. Maybe open the memory tab, see if it's a memory issue. Look at chat, please. Wait, hold on. I appreciate your suggestions, and I'm happy to look at the memory tab. But I'm just confused as to right now why my actual code isn't even seeming to run. That's running. Save KNN. Why is this not happening? I'm so confused. All right, memory. Where's the... I could also just do this with a little bit of training. Where's the memory? Here it is. I don't think this is... What's going on here? Let's look at the network activity. Whoops. I might just come back later today to finish this. It's 1:30. Network. Wait. Now you choose to work? Now you choose to work? And which code are you running? Now there's an error again? What? Oh, weird. Now my function seems to be working. Why do I not get the console log hello? That I'll never understand. Oh, but I think my model file is no good. Right? The one that it just did. It doesn't actually have the stuff in it, which is why it's definitely a memory thing. It can't. So we okay. So this is a bug. Okay. The bug is definitely an issue with the way that file saving is written in ml5. It can't do above a certain size, and it's only working when I switch to my file saving function because my file saving function is not actually saving the data. Okay. So yeah. So that's it. So that's definitely the issue, and I'm going to have to like debug this later. What I think I could possibly do right now, just to see if I could finish this, is I could limit myself to training just a smaller data set. So let me just try that. So all right. Oh, I deleted index.html again. How do I keep doing that? I know the camera's off. I'm frustrated. Today was going well until I had to go and ruin it. I keep deleting the wrong file. Delete this file. Okay. So let's see. I'm just curious if I limit myself to like 10 examples. Oh, that was too many. Down, left, right, up. That's good enough. Hey! All right. So maybe I could just quickly finish this off. with a smaller number of examples, and then we'll fix that bug in ml5. So please bear with me. I'm going to just save this like somewhere just in case I need it. All right, everybody. Okay, I'm going to try training this now and saving it. Here we go. So I'll speed this up for you. This is the right. Oh, that's too many. That's too many. I already did too many. I limit myself to 10. All right, it's time. I am going to try training this, and then I'm going to save it, and let's see how that goes. And I'll speed this part up. And then let's do left. Let's do up. Let's do down. All right, I've trained the model just with 10 examples each, so it's very small. Let's see how well it's working. So right, left, down, up. Perfect. So I'm sure I could do more to make it more accurate. To be honest with you, I just have to let you know the reason why I only did 10 is there's a bug right now where it was not working once I had too many examples. But hopefully by the time you watch this, it'll be fixed. And then you'll have to use ml5 version on the screen here, which is the correct one to use so that you aren't limited. Okay, so let me save. Yes, okay, I saved my model. And then I can go over here and I can drag it into where? Here. And now all I need to do is add some code to load it when the program starts. So what I'm going to do now is as soon as when the program starts, when the feature extractor is created, I'm going to wait to create the KNN classifier until that feature extractor MobileNet is loaded. And then I'm going to say KNN load model.json. And then I am going to, what am I doing? Now that's me loading the model, and then that probably has a callback too, which I could say function, error, result. You know what, I don't need to worry about the arguments here. I'm just going to say console.log KNN loaded. So this is the process. I have to load MobileNet, then I have to load my KNN model, and then it can just start, and then I can also actually say ready equals true, and I can say go classify. Because I can start classifying without having to train it first. All right, here we go. I think we're almost there. Let's refresh. I have a syntax error, line 57. Function, oh, this needs a parentheses semicolon to use the anonymous callback there. Get number of labels undefined. So it's working, but I got some weird error here, line 63. Let's see, what's just happened there? Line 63, if not ready and KNN number of labels. Oh, so you know what? In fact, let's actually just comment this out. There's no reason to wait for the training since I'm loading. There we go. Left, right, down, up. Oh, wait, this is left. Let's train it some more. There we go, I fixed it. Left, down, right, up. All right, so it's working pretty well. Now let's get it, finally, last step. Let's get it to control something. So I'm going to say background 0. I'm going to create a position. I'm going to say position. Let me just make a separate x and y. X and y. And I'm going to say x equals width divided by 2. Y equals height divided by 2. And now I'm going to say the label is nothing, and when I get a result, when I get a result. Hit me scrolling out. Where do I get the results? Yeah. When I get a result, I'm going to say label equals result.label. And then in draw, I'm going to do something very silly. I'm going to take out the image. I'm going to say ellipse x, y, 24, fill 255. And I'm going to say if label equals left, then x minus minus. Otherwise, if label equals, maybe I'll speed this part up too, right? X plus plus. Else if label equals up, y minus minus. Else if label equals down, y plus plus. And yes, my allergic reaction to the switch statement is still in effect apparently. All right, let's go. Here we go. Move to the left. Move to the right. I can't see myself. It would really help for me to see myself. Hold on. Let's not hide the video so I can see myself. And here we go. Move to the left, which is that way. Move to the left. Wait, hold on. Oh, I really need better training. This is terrible. I'm setting it to my, oh, okay. Guess what? I'm coming back later to fix this. This is it. I need to fix that bug because without it being trained well, it's not going to work well. This is all just a mess. I'm going to come back. Well, let me just, and also my left and rights are all mixed up. My brain is dead. I'm going to finish this another time. This is silly. I don't know why I'm so stubborn. But there was one thing that I wanted to do. Oh, yeah. I wanted to at least add a constraint. I'm not going to add it. OK. Everybody, thank you. Did you see my sending this to yourself of the future message, Simon? No, I did not see that. I will check that later. OK. I've got to end this. I must end this now. And hopefully somebody can help me solve this ml5 bug. And I'm just going to check and say, thank you to new members, Benjamin, Ty, David, and Sarab, and thank you to Mr. Ugla for the super chat. I have to go. It's going to be somewhat abrupt. And also I got myself completely confused with the left and the right because my left is, So I'm going to, if anyone can help figure out what that bug is, it doesn't necessarily have to be fixed and published to ml5 because I could just like rewrite little secret code to like actually save the model without that bug. And then I will come back ideally later today, but my next plan for a live stream was this Friday morning. I was going to try to do the fluid simulation thing. So if I don't come back later today to just finish this off, I'll come back on Friday to do the fluid simulation. All right. Okay, what do I need to notice? When are you uploading the code for the Fourier? I will do that soon. I don't know what Joel's referring to that I need to notice, but who knows? How big is that model.json? The one that worked, Alka, is 1 megabyte. So this one that I got to work is 1 megabyte. And I don't know if I try to save it now. I added a few. But I got to go. OK. Thank you, Alka, for volunteering to maybe look at that. Suresh is saying I can fix it. It's fixed now. Run. I don't know what's going on. OK. I'll see you, everybody. See you, everybody. I cannot speak. Goodbye. Let me hit this. Stop recording. Let me now hit, I'm still live streaming, aren't I? I gotta hit stop streaming here. Now this is really gonna end. Goodbye, everybody.